Alright, so let's have a look at this question here. This is going to be a hypothesis test, and let's just have a little look at what it's asking us. Oil company, they think they've developed some fuel that's going to increase the distance travelled for every litre of fuel, so it's more efficient, right? And so maybe they can get a higher price and charge a little bit more, make more profit. And so they do a test. So 10 scooters are filled with the normal fuel. You can see how far each scooter travels on 1 litre of normal fuel, and 8 scooters are filled with 1 litre of new fuel, and you can see the distances that the scooters travel on new fuel. Right, just to get an understanding of this, I've got a lot of writing on the iPad. You can see it down here, all this writing here. I'm going to explain that in a minute. But if we just switch out to the actual calculator, I've put the two data here. This is the old fuel, distances travelled by the scooters. This is the new fuel, distances travelled. It doesn't matter that we've got actually not equal amounts in each of the samples. It doesn't matter at all. What we're going to do first is we're going to just go and do menu, statistics. We're going to do some stat calc. I just want to find the mean. So I want to find the mean of the samples. All right. So let's do a one variable statistic. And it's actually two lists. Okay. So the variable I'm calculating with for the sample is the distance travelled. So the x1 list. Well, actually, can you see on the iPad here, I've very specifically called x bar 1 the mean distance for the new fuel, and x bar 2 here is the mean distance of the old fuel, and there's a reason for that when we get to the testing. So let's have a look. X1 is the mean distance of the new fuel, and x2 is the mean distance of the old fuel. Okay, and down here you can see 47.6 for the new, and compare that to the old of 42.4. Alright, so we're going to transfer that down to the iPad now. So for x bar 1, the mean for the sample, and that's using the new fuel, that's 47.6 on the iPad there, we'll put that in. And then for the old fuel, it's 42.4. Now that's great, because what we can see here, if you look on the right hand side of the iPad now, certainly for the sample, we can clearly see that the new fuel definitely does increase the distance travelled, all right? But that's just for the sample, and there was a 10 and 8 in the samples, right? But what we actually want to do is we want to try and make a conclusion, not for the sample, but for the actual whole population. So actually, if we did this test time and time again for hundreds, if not thousands, of scooters using the new fuel, would it still consistently produce, higher distances travelled? So that's the whole idea of a hypothesis test. We can't kind of test millions and millions of people or scooters from the population. We take a sample first, and then from the sample make predictions on the whole population. So let's get into the statistics test, the hypothesis test here. And so let's have a little look. See how we've set up the null hypothesis. So the null hypothesis is that the new fuel, and look, we use mu1 here for the population mean of the new fuel, and we use mu2 for the population mean distance for the old fuel. Okay, so we're testing. Let's assume that the null hypothesis, there's no difference. Okay, so the new fuel identical to the old fuel. All right, and then the alternative hypothesis here is that mu1, the population distances travelled for the new fuel, is greater than the old fuel. Okay, I think the question tells us to test at the 5% level of significance. That seems to be right. Yep, and there we go. So we've written down the null. We're testing the 5% level of significance. All that remains now is actually to go and get a t value, but more importantly the p value for the test, and then compare the p-value with the 5% level of significance. Okay, and remember our reasons for rejecting the null or not rejecting the null. Right, so here's how we're going to do a hypothesis test. First of all, I'm just going to click on the spare space next to the two data tables, the two lists here, and I'm going to go menu, statistics, and now instead of stat calc, we're going to go down to stat test. And the stat test we're going to do now is a t-test, and it's 2 sample. Now you can see z-test and t-test, right? T-tests, basically we're going to use a t-test when we don't know the population variance. Now on the SL Apps course, we would only use a t-test, okay? But generally in terms of testing, you can use a z-test or a t-test. Z-test is used if you know the population variance and standard deviation. T-test's used if you don't know the population variance standard deviation. Also, a subtle difference that Z-test's kind of used for maybe bigger sample sizes. T-test can be used for small sample size. So sample size here is 10 and 8, brilliant. But again, for the SL Apps course, we're always going to use this 2-sample T-test. So when we open it up, it's actually got data. So we've got the raw data here. We can also do a 2-sample T-test. We just have the statistics, as in the sample means and the number of items in each of these samples, okay? But we've got all the original data. Go. And now look, the list one here we are going to match with, can you see on the iPad? So list one we're going to match with population mean distance for the new fuel, all right? So here list one is for the new fuel, and then list two is for the old fuel. Now there's a reason for that, okay? And we'll show the reason down below. Frequency lists, well, these are listed one by one, okay? Now down here we're going to go for the alternate hypothesis. If you look at how the alternate hypotheses are listed, it's always mu1 compared to mu2, right? So mu1 on the left compared to mu2 on the right. So basically it's good to have mu2 as the kind of starting mean. So the starting mean is kind of the old mean, right, that we had before the new fuel was developed. So mu2 would be good to have as the old fuel. That's why I've got list 2 as the O here. All right. So here we're actually testing to see if mu1 is greater than mu2. So is the new fuel, does it produce greater distances travelled than the old fuel? All right. So that's why we choose lists 1 and 2. 1 is the kind of the new population mean, and 2 is the old population mean. You can do that on a consistent basis. Life's just a bit easier. So let's click this button. And then one final thing down here. And again, generally in statistical testing, what we're actually trying to do, we're combining both of those samples to make a prediction for the overall population variance, okay? And again, for SL Apps, we're always going to click a yes here. For more wider testing, we're going to say, sometimes we'll say no. We're going to say yes here. We're going to assume that the population variances, the standard deviations as well, between the two populations are very similar, in which case we can click yes. Again, for the SL Apps test, we're always going to click a yes here. And then we're just going to go, and we're going to overwrite. And then it is as simple as just scrolling down here and having a look at the p-value. So you can see this p-value here is 0.018, which is 1.8%. So let's just write that down on our iPad. The p-value is 1.8%. Now, if you think about it, 1.8% is well inside the critical region of 5%. So conclusion is definitely reject H0. And the reason is that our 1.8% p-value is less than the 5% significance level. And if you wanted to then write some kind of wordy conclusion, then you would say the new fuel does indeed result in better, well, maybe not better, maybe further distances travelled, right? You can match the same language as the actual question, but we're just kind of making up our own words here. Okay, and that's all you really have to do for a 2-sample t-test. I am going to just add a little bit extra on, because can you see that also on the calculator you've got this t-value of 2.3. So I'm going to write down the t-value. That's kind of the test value, 2.3. Okay, and now we are going to try and put it on this nice little diagram here, down here. Again, for an SL Apps test, you don't have to draw this. I just want to give you a bit more understanding. So we're actually going to shade in the critical regions on here. Now, so we're looking for the upper end, and if we're in this upper end of 5%, just highlight it in here. Beautiful. All right. So now let's have a little look. Our t value is 2.3, and we just know it's in the critical region, right? So it's actually in this critical region, and the exact value here is actually 2.3. So this x-axis scale is a scale for t-values. Okay, now the population mean, the sample mean for the new fuel was bigger than the old fuel, so we're going to get a positive t-value. If we'd have got a negative t-value, we'd be down here, and there'd be very little evidence to suggest the new fuel's any good at all. Okay, so that's the full picture there. If there was a two-sample t-test, then if there's a two-tail t-test, my bad, we'd shade kind of both parts here, but we'd actually still do the same thing. We'd get a p-value for the test, and we're always going to compare this p-value here with the actual level of significance. Okay, so just to summarize, this is a two-sample t-test. It's a two-sample t-test because we clearly see one sample, two samples. We definitely compare the two sample means with each other, but we can't really come to a conclusion about the overall population means until we do a proper hypothesis test. There's definitely evidence there to suggest that the sample means are different. Clearly, the sample mean for the new fuel is definitely higher than the sample mean for the old fuel, but we could have got that result by chance, even if these population means over here were the same. Okay, so that's why we click over here and we do a hypothesis test, just as shown on the TI-Nspire there.